welcome to session number 18 of the technical conference, where we have two presentations lined up on the topic methane monitoring, methane abatement and monitoring. As you all know, methane is a powerful greenhouse gas, which is roughly about 80 times more potent than carbon dioxide if you look at a span of 20 years. So abatement of methane will actually contribute more quickly to the climate change. But unfortunately, it has not received all the attention that carbon dioxide has actually received, primarily because the methane emissions are sporadic. They are spread across, geographies, and there are multiple sources which actually contribute to a small amount of total methane emissions. So, if we want to control and abate the methane emissions, it is important that we actually reliably detect the methane, effectively monitor it, and actually quantify the amount of methane that is being emitted from different sources. So with this background, we have two presentations lined up today. The first one is from Ms. Shagun Joshi, who's from SLB, and she will be talking on MethClone, an Internet of Robotic Things, a robotic platform that can quantify methane leakage. So Shagun, please.
Good afternoon, everyone. I hope you all had an engaging discussion with our global energy leaders yesterday. Thank you for joining this session today. I am Shagun Joshi, working with SLB as Data and Infrastructure Engineer. And today we will uncover the critical aspects of methane monitoring and abatement solution. Today, as a representative of SLB, I will showcase a digital innovative solution designed to curb the methane and detect the methane, titled MethClone, an Internet of Robotic Things platform that can quantify methane leakage and can contribute to cleaner and safer future. As rightly mentioned by our leaders, SLB is uniquely positioned to advance decarbonization. We are constantly developing energy transition technology, which helps us to reduce emission in oil and gas and accelerate the path to net zero. We are focusing on to develop the results and elevate the impact through collaboration with innovation and technology, which is deeply rooted in the culture of SLB. And of course, it is fundamental to drive this positive change. Let's start by looking at today's agenda. We'll be focusing on where SLB stands in terms of its decarbonization journey. We will then look at how destructive methane is for our environment and to the humankind. I will then showcase a digital innovative solution which is designed to quantify methane leakage in oil and gas facilities. I will then wind it up with the business value it will generate to us. Starting with where SLB stands in terms of its decarbonizing journey. As a global technology company within the energy industry, SLB is uniquely committed to being at the forefront to drive the digital innovation in the energy industry. Within the SLB technological and sustainability scope, we have three priorities aligned with our commitment to net zero. That is climate action, nature, and people. As we have looked at the priorities we have set for our energy transition journey, let's look and see the targets we have built to accelerate the path to net zero by 2050. As a global technology company, we are focusing on to reduce the greenhouse gas emissions and achieve the net zero by 2050 by utilizing scope 1 and 2 and scope 3. When we talk about scope 1 and 2, we specifically mean that reducing emissions which are coming from our operational and facilities. And when we talk about scope 3, we are meaning that we are reducing our emission utilizing our technological advancements. To build our comprehensive interim targets, we are trying to reduce the greenhouse gas emissions by 30% by 2025, 50% by 2030, utilizing scope 1 and 2, and 30% by 2030, utilizing our scope 3, and pave our path to net zero by 2050. The question arises, why it is beneficial for us to address methane? As mentioned by our speaker, methane is a potent greenhouse gas and it's contribute to 50% of the overall oil and gas industry's greenhouse gas footprint. During the recent survey done by Environmental Protection Agency, it was concluded that methane emission across the entire oil and gas value chain, there is upstream oil and gas operation, which leads to 3/4, that is 68% of the total emissions, and it is crucial for us to address methane utilizing intelligent innovations within the technological space. Looking at the adverse effects of the methane leakage within the different locations, we can conclude that there is a total loss, which you can see as it is increasing from the period from 2010 to 2021. According to the International Energy Agency, it has led to total loss of $3,900 million US, with over 2,600 plus incidents and 1,500 plus human fatalities across the globe. When we discuss about the effect of any greenhouse gas, we usually use the term global warming potential of any gas. Global warming potential refers to the emission of 1 kg or 1 ton of gas, which will absorb over a period of time relative to the 1 ton of emissions emitted by the carbon dioxide. We can see that as per the studies by US Environmental Protection Agency, methane has a global warming potential of 28 to 36 with a period of 100 years of time, and within the shorter time frame, that is measured over 20 years, it has soared to 84 times compared to the carbon dioxide global warming potential. Let's look at what are the current technologies which are in market to manage methane or to detect methane. Notable ones are measurement, detection and repair, infrastructure hauling, and portfolio optimization. As we move towards the portfolio optimization, it is complicated to implement those solutions within the oil and gas fields, and it is usually associated with high capital expenditure and operating expenditure. Let's look at the current challenges we are facing right now with the current technology in market. We have the inconsistent reporting system. There is no tool which is reporting the methane concentration as of now in the real-time environment. We also have an unavailability of automated decision-making qualities, which helps the safety officer in charge of the field to take those decisions effectively. We also have business consideration and regulations attached with the drawbacks in the current technology. We have non-standardized metric system, which means that we don't have any emission tool in place which can report our methane, our daily emissions under a single platform. And due to not having enough tools in the market, we are losing a lot of data within generating the emissions. And we also have limited solution expertise. There are not enough skilled staffs and the officers which can help us to monitor the methane effectively. To make our oil and gas operations clean and green, I would be showcasing MethClone, an Internet of Robotic Things based platform that can quantify methane leakage. MethClone, an Internet of Robotic Things based platform, has different mechanical architecture attached with it. First one being the LiDAR camera, It helps you to navigate and monitor the target area where the meth clone has been explored. Second one being the automated methane leak detector with a pan tilt unit. Automated methane leak detector belongs to the family of tunable diode laser absorption spectroscopy. When we talk about TDLAS sensors, when the infrared light passes through the gas plume, the gas absorbs a portion of light which then detects and compute the methane concentration in parts per million. We also have provided an additional technological advancement within the robot, which is equipped with pan tilt unit. The automated methane leak detector with a pan tilt unit helps you to compute the varying concentration of methane at different angles. Third one being the laser scanner. Laser scanner is mounted so as to compute the geometry of the target space area. All of these mechanical stage has been mounted on an all-terrain robotic vehicle. And ATV, for example, helps you to access the remote places where the handheld sensors, for example, what we are using nowadays and called as conventional sensors, may not be able to reach there. The main problem which aroused during the design of the mechanical stage was we were not getting the, just a second. We were not getting the methane concentration in a real-time environment. We have integrated our meth clone with Arduino controller and Wi-Fi module. The data from automated methane leak detector is logged with Arduino IDE controller, which sends the data to an IoT database server, which then helps you to visualize the data in a real-time environment and take those automated decisions regarding the facility target area. I'll be showcasing what data we can generate by utilizing our IoT database server and what all features we are getting over the server. If you closely look at the representation, we have the location of meth clone and we also have the methane emission maps. The methane location helps you to see where the meth clone is located as per the time period, and it also helps you to navigate through the different positions it has traveled across. It also gives you the emission maps. As you can see here, we have kept the meth clone, and around the meth clone we have kept the methane bottles. As we move away from those methane gas concentration, the concentration of methane gets lowered down, and you can also generate daily methane emission report with respect to different intervals of time. So this whole architecture is equipped with a robotic platform that computes the methane concentration for you and also gives you the real-time data through utilization of an IoT server. Let's discuss what differentiates meth clone from the existing technology in market. It provides you with a unique selling proposition of methane concentration, where it gives you a red alert when it goes beyond 50 parts per million, which is crucial for the officers which are employed in the field to take those informed decisions and repair those leaks as soon as possible. Integration of IoT will also lead to secure and accurate data analysis without any human intervention. Third one being, you can also utilize meth clone to accurately detect the location of the target repair area, and it will help the officers in charge to position those equipments which has a methane leak coming out from. Let's look at the challenges we have solved by utilizing meth clone. We now have a consistent reporting mechanism. We have an automated decision-making technology. To regulate the business consideration, we are also providing with the low capital expenditure and low OPEX. We have a standardized metric system in place by utilizing meth clone, and we have real-time monitoring expertise without human efforts. When we talk about energy transition journey, we focus a lot on sustainable development goals outlined by United Nations. By collaborating with technology and by utilizing meth clone, we are solving and we are achieving 4 major sustainable development goals. That is SDG 3, which focuses on good health and well-being. SDG 9, which focuses on infrastructure. SDG 7, which focuses on affordable and clean energy. And 13, which focuses on the climate action. Let's look at the business value it will generate to us. This is the in-depth analysis which is computed by Modor Intelligence, and we can see that there is a high demand of gas detection system in Asia and with moderate demand in South America and Africa, which is expected to increase to 9.3 million US dollars by 2029 with a compound annual growth rate of 9.4%. By this chart, we can see that we have a huge market to capture, and we are slowly moving towards the market and capturing all of it. Let's look at what adoption of this revolutionary prototype will help us to achieve the net zero target by 2050. We'll be able to prevent the annual loss of 34 billion US dollars in leaked and vented methane. It will also help us to collaborate with technology and achieving the net zero by 2050 and also aligning with the Paris Agreement. It is helping us to reduce our greenhouse gas emissions annually, and it is also helping us to generate an annual revenue of $7 million by utilizing meth clone and make SLB the leader of net zero. Thank you everyone for your patience and time. I am now open to suggestions, questions and feedback.
Thank you so much, Shagun. We'll take the question answers towards the end. So you may take your seat. Our next speaker is Ms. Audrey, who is the President and CEO at Questor Technologies in Calgary, Canada. And she will be speaking on improving methane emission detection and quantification with a holistic top-down system approach.
Good afternoon, everyone. Can everyone hear me okay? So I've spent the last 25 years focused on solutions around reducing and eliminating methane. And one of the things that I'm going to talk about today is, where does methane show up in our operations? Where are we emitting it? And then to talk about how can we solve the methane issue. So in our industry, as the speaker before said, methane has a global warming potential that is 86 times worse than CO2. 40% of the methane emissions that come from our industry haven't been accounted for. According to the World Bank, every day we flare and vent over 14.5 billion standard cubic feet a day of associated gas. Not only does that have a climate change impact, but it's an enormous waste of energy. That amount would power a third of Europe's energy needs, and we've been wasting it for the last 60 years. With the advent of satellite technology and drones and airplanes, the satellite imagery is showing that we're releasing over 1 gigaton of CO2 equivalent coming from non-routine flaring. In addition, the methane that is leaking from our flares and vents contributes about the equivalent of 2 billion tons of CO2 equivalent. In summary, the magnitude and the contribution that methane is making from our industry is quite significant in terms of climate change. Now, there's an elephant in the room. And so one of the reasons that there's a big disconnect between our bottoms-up and tops-down reporting is we make an assumption, and we have for a long time, that a flare is 98% efficient. All of the research that is being done with universities around the world, including the drones and satellites, are showing that we're leaking methane from our flares, and they're not 98% efficient. I would even hazard it to say that there isn't one number for the efficiency of a flare. It's dependent on the wind, it's dependent on the composition, the size of the droplets, the design of the flare. And it depends on what's happening at your facility. In my 40 years of experience in oil and gas, there's no such thing as a constant flare rate and a constant composition. It's always changing at our facilities. The other area that we don't account for is maintenance. When we pig a pipeline, when we do replace valves on pipelines, we're venting the volumes that are in the pipeline. When we unload a well, we're venting methane. When an engine goes down and it's attached to a compressor, we do a soft start, we're venting. We don't include all of those methane emissions. But here's an enormous opportunity for us to reduce greenhouse gas emissions in a very cost-effective way. And then finally, as an industry, we've made a distinction between non-routine and routine flaring. So we talk a lot about the routine, which are some of the smaller volumes, but that's probably less than 20% of our actual methane emissions. The non-routine, which are ESDs, equipment failure, maintenance, is a far greater volume that isn't reported. So that's one of the reasons we see this disconnect between the two. And Environmental Defense Fund did a big study in the Permian looking at methane emissions. And what they're finding is we've underreported our methane 3 to 5 times. So this is a big issue, but I think also an opportunity. So this was out of the Environmental Defense Fund report, and I'd had a chance to talk to David before they did the survey. And he was quite surprised after the survey to find out how large the methane emissions were coming from flaring. So in other words, the belief is we won't solve our methane problem without solving the flaring problem. And this is just a summary. What they found in this study was that of the 3,000 flares, 11% were malfunctioning, 5% weren't lit. But it was one of the biggest sources at facilities of methane emissions. Now, I want to shed some light on where some of this is coming from. One of our biggest challenges is some of our lower producing wells. The challenge there is, can you afford to put in a pipeline? How can you afford to gather it? And really what you're looking for is cost-effective solutions that actually make sense. A significant portion of our methane is coming from our wells, from our gas processing, midstream facilities, and pipelines. Reality is our methane comes all the way from drilling a well all the way along the value chain to delivering that molecule to the consumer. And so what I want to show you is our global experience, where we've had a chance to, in the top right-hand picture, is drilling and completions in Europe, and our client happened to be Schlumberger and E&I. The picture below is creating that's a compressor station, and what we've done there is created a zero flaring venting site by redesigning the site and making sure all of that gas is rerouted to a thermal oxidizer. So we can guarantee that anything that comes to us is destroyed at 99.99% efficiency. The pictures on the left-hand side are at large gas processing facilities. So one is in Indonesia, the other is at Zohr in Egypt. And once again, our client there was Schlumberger, or SLB. But what we're showing there is not only have we dealt with the routine, but also the non-routine emissions. Every single one of these sites, and the top picture is a rail car loading facility. So I know in our discussions with IOC and ONGC, we're looking at some of the loading facilities and dealing with these vented volumes in a much more effective, safer way. So, a couple of key points that I want you to take away. There isn't such a thing as a blanket emission factor. The emissions from a drilling site are different from when you're drilling, completing, and producing a well. Emissions at a compressor station are different. Likewise for pipelines. So we can't lump them all together and use an emission factor. One of the things that we focused on as a company is taking a proactive approach along the entire value chain, recognizing the uniqueness of each stage and designing the site or retrofitting the site to deal with the fugitive emissions, the flaring, and the venting. So we have patented technology, and we're doing our combustion very differently from most of the companies that are focused on it. Our patent allows us to bring in these volumes, mix them, have high residence time, but the one single unit can handle multiple streams of low pressure and high pressure. And so what you see there is actually units at a rail car loading facility. And we've created a facility that has no flaring, no venting, and we're guaranteeing zero emissions of methane, but also other harmful products like volatile organic compounds, BTEX. So we've truly not only impacted climate change, but air quality and safety. I wanted to show you this picture, and this is in pipeline maintenance. So the unit you're seeing there is actually currently combusting 5 million standard cubic feet a day of methane. As you can see, there's lots of houses around that site. There's cars, there's people. No one has run away, no one is scared. Of the 17,000 houses around this site, there was not one complaint. Now, what's also significant, if you vented 5 million standard cubic feet a day of methane, and depending on which global warming potential time frame you use, and I'll be very conservative and pick 100 years, that 5 million standard cubic feet a day of methane would put 2,700 tons of CO2 equivalent into the atmosphere. By cleanly combusting it and turning the methane to CO2, you've reduced your greenhouse gas emissions 90%, but here's the best part. You've done it at a cost of less than 10 cents a ton of CO2 equivalent. Not only have you reduced greenhouse gas emissions, you've improved safety, you've improved air quality, and the other big advantage, because we're combusting in a closed chamber, that volume of gas releases 220 million BTUs an hour. It's an enormous opportunity to do something useful with the gas. So, the projects that we've done, so in the top left-hand side, we've taken a slipstream of our hot gases, and we're generating power at this remote site. So we've eliminated dirty diesel power generation that's expensive and used the waste gas that was being vented, and it had H2S in it, and we're running this site using the energy of site. The picture below shows us using our heat to treat water, and the project that we're working on in the Middle East with Total is to use the heat, so recover the heat within our unit and use it to heat up the oil. This oil is waxy, and they were burning diesel or burning some of the oil production to help heat up the oil. Instead, we're going to use a waste stream, which was their gas that they were flaring and venting, to deliver value and reduce costs. One of the big advantages, and we are the only company in the world that has obtained ISO certification, and it's ISO 14034, which is a new ISO standard on environmental technology verification. We are guaranteeing, and our ISO certification says that when a waste stream comes to us, we're able to combust it at 99.99% efficiency. And what you see on this slide is some examples of testing that was done in North Dakota, but the regulator in North Dakota, the regulator in Colorado, the EPA, all recognize our high performance and allow our clients to recognize that. So when you talk about energy transition, it allows you at your sites with great certainty to tell the regulator, the community, your shareholders and investors that you've truly reduced your emissions and are now producing the cleanest hydrocarbon molecule with the lowest carbon footprint. Now, everyone's got goals around net zero. What you see here, and the first part of the picture was when we were talking about vented methane, and that was the pipeline blowdown. So you can see from that, taking methane and turning into CO2 is a 90% reduction in GHG emissions, cost of 11 cents a ton. Or if you purchase that unit, when you look at the carbon tax we have in Canada we have to pay $80 per ton of CO2. That means if this volume was taxed, you would have to spend $200,000 a day on a carbon tax. By cleanly combusting it, you drop that to $20,000. Because we can use that energy and generate power, and in this case, we're generating about 4.5 megawatts of power from that gas, because that generates a revenue stream, we're actually reducing our carbon for a revenue stream of $200 a ton. We have about a 1-year payout on that investment. Our carbon tax drops to $15,000. But because of our high efficiency, what's coming off the top of our stack is nitrogen and CO2. That stream can go to a fertilizer plant, so we've got rid of the CO2, or we can take the nitrogen and CO2, separate it, sequester it, use it in products. So in other words, we've got to net zero for zero cost, and we've not only reduced greenhouse gas emissions, but we can provide clean energy to the community. We can reduce operating costs. But at the end of the day, this is one of the easiest ways for us to have an impact on the temperature rise. And the best part is it makes business sense. The other area that we've been working on, and because regulators recognized our high efficiency, we've got a great continuous emission monitoring system. And we've also created an emissions excellence center where we monitor our units. By looking at how we design sites, we can make sure there's no flaring and venting, and then use tools like drones and sensors to demonstrate and confirm that we truly have zero emissions of methane at a site. This allows us not only to help our clients report to regulators, but it allows them in their ESG reporting to have solid numbers that can be audited and demonstrated that this molecule produced at this refinery or this production facility is the lowest carbon molecule. And so finally, these are just some examples of the wins we create with community for our clients. The first one is an example of 80 wells within the city of Calgary that have 34% H2S. Less than 1% kills you. But we followed the workover rig for over 7 years within the city, and there was not one complaint. Sometimes we were crossing the elementary school, the Starbucks, or in someone's backyard. The middle one is a thank you letter from a landowner. It's very seldom that landowners write thank you letters. And the final one is, with all the focus on ESG reporting, our client in New Mexico in the United States uses this on their Facebook page to talk about the things they're doing to have an impact in a positive way. And that concludes what I wanted to say today. And I'm going to invite you to come to our booth. It's just across the hallway at 3H20, and I've got my colleagues and partners who are working with me in India at High Tech. So I really welcome you to come and chat with us. Thank you.
Thank you, Ms. Audrey. Request you to be please on the stage, be on the stage right now. And Shagun, if you can join her on the stage. Now we open the floor for question and answers. So if you can put your questions. Before the question, you can identify yourself and then tell who the question is directed at.
I hope you guys are going to ask some tough questions.
Okay, so there are no questions. We can wind up the session now. Thank you, Ms. Shagun, Ms. Audrey. Thank you so much. Thank you all the audience, and thank you IEW, the organizers of IEW. Thank you.
Thank you so much, everyone.